This is the 2017 AP Calculus free response questions. These are the actual questions for the test given in May of 2017. And number one, we have a table. So it says a tank has a height of 10 feet. The area of the horizontal cross section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. Okay, so this time they put the x value on top, feet, and the y value, a of h, on bottom. Okay, so you can think of the top set row as the base of each rectangle, and the height would be the bottom row in your table. So part A says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Okay, so we're going to have 3 rectangles. That'll be the first one. That'll be the second one. That'll be the third one. And we've got to use the left height. So our first height will be 50.3, our second will be 14.4, our third one will be 6.5. Okay, so the base of our first rectangle is from 0 to 2, so 2 is our base, and then our height is 50.3. And you do get a calculator on numbers 1 and 2, so you won't have to do this in your head. The second base is from 2 to 5, so that base is 3, and then that height will be 14.4. And then the third base goes from 5 to 10, so that base is 5, and the height is the left number 6.5. So if you plug that in your calculator, you get 176.3. Now you need to get the units right. We're estimating volume, so that would be cubic feet. It's important to get the units right on the test. Okay, part B says, does the approximation overestimate or underestimate the volume of the tank? Well, this is a decreasing function, right? Starts up at 50, and by the time we get to 10, we're all the way down to 2.5. So if you're making rectangles with a left sum, see how you have that extra spot part right there? A left sum overestimates. Okay, so for the AP people, you want to like underline that or circle that. A decreasing function. Of course, if this were an increasing function, it would underestimate it, a left sum. All right, so if you're not sure, just kind of draw out, is this function decreasing or increasing? Draw it out and draw a few rectangles like that. Part C says the area in square feet of the horizontal cross section at h feet is modeled by the function f. F of h is pretty fancy. It's 50.3 over e to the 0.2h plus h. Based on this model, find the volume in the tank and indicate units of measure. Okay, so we're summing up something. So that means we're going to be accumulating or integrating something. And so if f of h is the area, we can get the volume by adding up all the areas. Okay, so that's from 0 to 10, right? Because we go from 0 to 10 up here, of just f of h. Now, you don't have to write all that out again, but you will have to put it in your calculator. All right, and of course, dh, make sure you write that out for your graders. And then when you put that in your calculator, go ahead and give that a try, and let's take it out to the thousandths place. So it'd be 101.325 cubic feet. Okay, so give that a go in your calculator and see if you can get that. Now part D, I have worked this for students before, and I have found it to be one ultimately just worth skipping. You probably won't see one like that, and of all I've worked all of these from 2010 on for students, and that's the only one I've seen like that. So I'm going to say part D is worth skipping. It is a related rates one, but it's got a special twist. So let's skip part D. You definitely want to be prepared to do related rates, and we're going to work a lot of problems with related rates. But this one's just got a little bit extra zip in it that I don't think is worth going over. Okay, that's number one. Go ahead and pause your video if you need to. Go ahead and... All right. Number two says when a certain grocery store opens, it has 50 pounds of bananas on the table, and customers remove bananas from the display table at a rate modeled by... I'm going to go ahead and write this out. You wouldn't necessarily have to, but f of t is equal to 10 plus 0.8 t times the sine of t cubed over 100. So that's the rate at which they remove bananas. And then after 3 hours, workers come out and add bananas to the table. So this grocery store, this must be Whole Foods or something, because this grocery store literally studies their banana removal and their worker banana addition to the point where they have a mathematical equation to model it. So that is very impressive. I really don't think they're doing that at Walmart or Banks Market. So 3 plus 2.4 natural log of t squared plus 2t. Okay, and the removal goes from 0 to 10 hours, or excuse me, 12. And the addition, the workers don't get started until hour 3. So it goes from 3 to 12. All right, so A says how many pounds of bananas are removed from the display table during the first 2 hours the store is open. Okay, how much? You're adding something up, so you're going to integrate. All right, so you don't have to write that equation all out. You do have to type it in your calculator, but it's going to be from 0 to 2 of f of t dt, and the graders are cool with you just putting that down, and that's 20.051, and the unit is pounds. So that's one. Go ahead and plug it into your calculator to get fast in your calculator and practice that, but you know, that one's not bad at all. Part B says find f prime of 7. Okay, well, f prime of t, I'm going to go ahead and take that derivative by hand, but I'm going to show you how you can do it in your calculator much faster. Okay, so f prime, okay, the derivative of 10 is 0, and then we have a product rule here. The first, 0.8t, times the derivative of the second, well, that would be times cosine of t cubed over 100, times 3t squared over 100. So that's the derivative of the block, plus the second sine of t cubed over 100 times the derivative of the first, so times 0.8. So that didn't take too long, and you'd then have to go and type all that into your calculator and then put a 7 in for t. And if you do that, you'll get minus 8.120, and that's going to be pounds per hour. But I want to give you a way you could do this in your calculator. So first, you want to take the original function f of t and graph it. Okay, not f prime of t, graph f of t. All right, so hopefully you can read this. All right, I plugged it in. Okay, I plugged it in. Now I'm going to go to F2, and I'm going to, it doesn't really matter. We'll just zoom standard and see what happens. All right, it's graphing it. A lot of the graph is off of the page, but I don't really care about that. Okay, so I'm going to show you what you do then. Go to, if you'll look at the instructions, oh, my head's probably in the frame here. Go to F5 for math. And then go down to 6 for derivatives. Hit enter. And then a dy dx pops up there, so hit that. And then dy dx at what? And just type in 7. And then hit enter. And it tells you negative 8.119. So that's negative 8.12. I think it would be faster, since you get to use your calculator. All right, so graph ft, and then it doesn't really matter, but you can zoom standard. You could zoom in if you want, you could zoom out if you want. But graph it, then go to F5, and then go to derivatives, which is option 6, and then just type in 7, and it'll give you negative 8.119, but you'll go, it's fine, negative 8.120. And it's a rate, right? At 7 hours, they're removing pounds per hour. They want you to get the unit right, so because they believe that's what makes, that's, you know, shows them that you understand. And then you have to explain the meaning of f prime of 7. Okay, so the meaning is after 7 hours, customers are removing bananas at a rate of, so they're removing, that's why it's negative 8.12 pounds per hour. Okay, so I do think it's faster to graph that than to take the derivative and then try to plug 7 in. Okay, pause the video if you need to, and we'll hit parts C and D. Okay, part C says, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? And then you have to give a reason for your answer. Okay, well, you know that bananas are being removed by the function f of t. So let's find f of 5. Okay, so you're just going to plug that straight into your calculator. 10 plus 0.8 times 5 times the sine of 125 over 100, right? Plug that in. You'll get f of 5 is 13.8. Let's get g of 5. That's how the rate at which bananas are being added by the workers in the grocery store. Okay, when you do that, you'll get 11.553. So, since, here's your explanation, f of 5, removal, is greater than g of 5, which is replenishment, the amount of bananas is decreasing. Okay, so that's pretty easy explanation and not a real hard one to get. Part D says, how many pounds of bananas are on the display table at time t equals 8? Okay, so the way you figure it out is what you start with, which is 50 pounds, plus G of t, which is how much you added, minus F of t, which is how much was removed. So it's going to be 50 pounds. Okay, so it says that you start with 50 pounds on the table, plus, now workers start at hour 3 adding, so it's 3 to 8 of G of t, minus workers, our customers start removing at hour 0, so 0 to 8 of F of t. That's all the work you have to show, but you have to get it all in your calculator. I'll go ahead and show you the numbers. Of course, you've got the 50. G of t, 3 to 8, is going to be 58.964. So give that a try. And then F of t, 0 to 8, is 85.617. So it's good they started out with 50 pounds, or they would have not had any bananas on the table. 23.347 pounds. So as someone who worked at a grocery store in high school, I can tell you that they are not this sophisticated. The produce workers are not using calculus to figure out when to add produce to the table or the display. They are just using their eyeballs. Okay, I will do number 3 if you want to go ahead and pause the video. So number 3 has a graph of f prime. So I'm going to go ahead and try to draw that in. Okay, so you've got a semicircle, and then you've got a triangle like that, and then a line like that. Now I'm going to go ahead and kind of draw that there. We are at, here we're at -6, here we are at -2, and then that's at 2. This is the point 3, 2, so you got a height of 3 there. And let's see, that value, 1, 2, 3, 4, 5, this is at 5. Now, I probably should have drawn this just a little bigger, but I'll put in red what the areas are. So the area of this triangle above the curve is 4. So that's 1/2 base times height. 1/2 base of 4, a height of 2. And then you have to remember that the area of a circle is pi r squared. This is a semicircle, so this would be 1/2 times pi times r squared. The radius is 2 for that circle, so it'd be 1/2 times pi times 4. So that's going to be 2 pi. And then the area of that triangle, 1/2 base times height, is 3. So we need to know all that information to answer the questions. This is a graph of f prime, so they just tell you it's a graph of f prime. You're not having to do that, plug in the upper limit business and all that. So part A, and this is a problem worth studying because we didn't do this in our textbook. So part A says find the values of f of -6 and f of 5. Okay, we did one of these the other day. So f of -6, you know that f of -2 is equal to 7. That's in the original problem description. So we have to start there at 7. Start at a spot that you know, and then you integrate from that spot you know, -2 to -6. Okay, and then that's just going to be the area under the curve. But we have to get the smaller number on bottom. So we have to make it negative and go from -6 to -2. So what's the area from -6 to -2? Well, it's 4. So that's going to be 7 minus 4, which is 3. Again, it's the area there, but we had to make it negative because we had to switch the limits of integration. Now let's do f of 5. Well, f of 5 is going to be our starting point 7, and then we integrate from -2 to 5 of f prime of t dt. Well, what's the area from -2 to 5? Well, it's going to be 3 above and 2 pi below. So it's going to be 7 minus 2 pi plus 3. So that's 10 minus 2 pi. So we're going to use those values again. But that is f of -6 and f of 5. All right, so not hard to do if you understand it. It's just some pretty easy areas that you got to figure out, but it's not one we worked on a lot from the book. Okay, so let's remember those numbers, 3 and 10 minus 2 pi. All right, part B. On what intervals is f increasing, and justify your answer? Well, f is increasing where? Have you memorized the rule yet? Okay, it's going to be where f prime is greater than 0. Okay, so that's going to be -6 to -2. And the reason I'm using brackets is because they use brackets in the original description of the problem. Okay, they got that bracket. So they're including the endpoints. So -6 to -2, and from 2 to 5. And that'll do the trick. That's a good enough description of why you picked that. It's because f prime is greater than 0. Okay, let's see if I can fit part C on here. It says, find the absolute minimum value of f on the closed interval -6 to 5, and justify your answer, the absolute minimum. Okay, well, minimums occur at endpoints, so we have to check the endpoints potentially, and where f prime goes from negative to positive. So that occurs at x equals 2. So we have to check x equals 2, and we have to check our two endpoints, -6 and 5. Okay, we've already figured out f of -6 from part A, and that was 3. We figured out f of 5 from part A. That was 10 minus 2 pi. So now we need to just figure out that critical point, f of 2, and see which one of those three options is the least. Okay, so f of 2, we're going to go from, it's going to be 7, so it's just like part A, plus from -2 to 2 of f of t dt. So that's 7 plus, and then what's the area from -2 to 2? Well, it's below the x-axis, so it's going to be 7 plus -2 pi. So that's going to be 7 minus 2 pi. So that's 7 minus 6.28, so just a little bit, little under 1, about what, 0.72? So that's going to be your minimum, because 3 and 10 minus 2 pi are bigger than that number. So that is your absolute min. All right, pretty cool, eh? All right, I guess that's in the mind of the beholder. Yeah. Oh, dadgum, I shouldn't have erased that because we have part D. Okay, so I'm going to just quickly, I don't think I need a perfect drawing for part D. So we've got doink, doink, wink, wow, wow. Okay, so I don't think I need the areas there. So we know that this is -2, this is -6, that height is 2, and 3 is right there at x equals 3. So part D says for each f prime of -5 or f prime double prime of 3, find the value and explain why it does or does not exist. Okay, so f double prime, again, this is a graph of f prime. F double prime at -5 is equal to the slope. Remember, it's the derivative. F double prime is the derivative of f prime. So that means it's the slope at x equals -5. Well, how would I figure out that? That's just going to be the change in y over the change in x. So we can easily figure out the slope of that line. It's going to be y2 minus y1 over x2 minus x1. Okay, so y2 is 0. y1, right, is going to be 2. x2 is -2 minus -6. So that's -2. Again, I'm figuring out the slope between -2 and -6. That'll be the slope at -5 because it falls in between, over 4, which is -1/2. All right, and that explains I think that does the trick. That explains it. Slope at x equals -5. Okay, f double prime of 3. That's going to be the slope at x equals 3. Well, can you get a slope? Is it the downhill one? Is it the uphill one? Okay, so f prime of 3 is not differentiable at x equals 3 due to sharp turn. All right, so that means f double prime of 3 does not exist. Okay, so f double prime of -5 does exist, and the value is -0.5, and f double prime of 3 doesn't exist because it occurs at a sharp turn. And remember, f double prime is just the derivative of f prime, so you would treat that just like if this was a graph of f and you were trying to get f prime. So that's it for today's video. Covers numbers 1 through 3 on the 2017 free response, which both of my students who took this test passed it. One made a 4, one made a 5, so they had a good outcome on this test. So I'll see you next video.